Welcome back, class. Today what we're going to discover is how to find a quadratic from its graph. The goal of today's lesson is to find the equation of a quadratic function from its graph using four things. One is the x and the y intercepts, two are the axes symmetries, three are the vertices, and then the fourth thing is find it from a set of points. So by the end of this lesson, you're going to be able to do all of that. So let's get started. All right, so we're going to start off saying if we are given sufficient information about a graph or about, we're given sufficient information on or about a graph, we can determine the quadratic of whatever form is required, okay? So we've been doing a lot up to now, and this is bringing us to one of the main purposes. So we're going to find the equation of the quadratic with the graph. So far we've been using the equations to draw the graphs. Now we're going to use the graphs to come up with the equations. So let's start with example 15. Very simple. Since the x-intercepts are, what are the two x-intercepts? Good, -1 and 3. That's where the graph crosses the x-axis. All right. What about this? We don't need that. We can use these x-intercepts to create our equation. Now, in case you guys forgot, the way to create the equation with the x-intercepts are, x-intercepts are used in the parentheses, remember? So we have a, we don't know what a is. A can be any constant, positive, negative, or a fraction. And then it's going to be multiplied by two pieces. Using the intercepts, if I want this piece to be 0, and this is 1, I can make this x, the opposite of 0 is +1. All right? Times x minus 3. So look what happens. X plus 1, x minus 3. -1 plus 1 is 0, making the whole thing 0. 0 times this is also 0, making the whole thing 0. All right? Very, very important stuff to do. Right away, I don't know why my 1 wasn't blue. All right, so when x equals 0, okay, here's the y equals 3. So now we've got two bits of information here to help us solve our problem. Seems pretty easy, right? Therefore, can I come up with an equation? I can use my equation right here, along with this y-intercept, so I'm using the x and y intercepts, to solve it. Now we don't know what a is, so we want to solve for a. So I can take this 3 and I can plug it in for y, and I can take x equals 0 and plug it in for both these zeros. So if I do this, I get 3 equals a times 0 plus 1, because x is 0, times 0 minus 3. X is 0. I'm taking the 0, putting it in for both x's, taking my 3, putting it in for y. Now, 0 plus 1 is indeed 1. All right, that was pretty obvious. And 0 minus 3 is -3. So 3 equals a times 1 times -3. -3 times 1 times a is -3a. So how do I solve for a here? I can divide both sides by -3. Meaning a is going to be what? 1. -1. 3 divided by -3 is -1. So that means my quadratic is going to be y equals a, which is -1, times x minus 1, times x minus 3. And that's it. Can we write this a little bit better? Well, you don't have to put the 1 there, -1 times anything. Instead of, this is perfectly okay. If you want though, what you can do is, you can just put the negative out front. Yes, you could FOIL this to change it as well, but you could just leave it at either one of these. It's perfectly okay. Why don't you try to use that to solve for b? Go, go, go. All right, you should be done with that by now. The graph touches the x-axis, so only one x-axis at 2. All right, so the equation we're going to use is going to be y equals a times, do you remember what the equation looks like when you touch the axis? It's going to be x minus 2, and how many do you have? 2 squared. Okay, so it's a times x minus 2 squared. Remember, you're always going to need to have at least an x squared when you have a parabola. You can't just make it a times x minus 2, or else it would be a linear graph. Right? Now, when x equals 0, what does y equal? 8. So we're going to use that point to find a. So use that to find a. And then you're going to do a bunch on your own. All right? Should have plugged that in. You plug in the 8 for the y and the 0 for the x. You get 8 equals a times 0 minus 2 squared. 0 minus 2 is negative 2. So 8 equals a times negative 2 squared. Negative 2 squared is 4. 8 equals 4a. So I'm going to divide both sides here by 4. And a equals 8 divided by 4 is 2. All right, now since a is 2, put it back into the equation. See what we get. All right, y equals 2 times x minus 2 squared. That's all there's to it. And then you're done. You just came up with a quadratic equation from the x-intercept and the y-intercept. The two x-intercepts and the y-intercepts. That's all there's to it. Your answer is going to be either in this form or in this form. Okay. Now what I would like you guys to do is problem number 1, A, B, C, D, E, and F. So there are 6 problems right there. Go. All right. Guess what? Time to move. First off, the x-intercepts here. Gave you enough time. You should have been done this. I paused. 1 and 2, right? So that means this is going to be y equals a times x, and it's always the sign opposite this. X minus 1, x minus 2. Okay, so x minus 1, x minus 2. Because if you plug these in here, you want to get 0 as an answer. Okay, because technically it's like x minus h equals 1. X minus k equals 2. So you want to find out what those numbers are. So now to solve for a, when x equals 0, what does y equal? 4, right? 4 equals a times 0 minus 1 times 0 minus 2. 4 equals a times negative 1 times negative 2. 4 equals 2a. Therefore, your a equals 4 divided by 2, which is 2. Okay? And your final equation is y equals 2 times x minus 1 times x minus 2. All right? Nice and easy. I don't think there's any difficulty level there. So then you're going to do next one. All right? X-intercept, well, there's only one. It's at 2. It's going to be y equals a times x minus 2, and don't forget the squared. You're going to plug in 0 when x equals 0, y equals 12. That's your y-intercept. So you have 12 equals a times 0 minus 2 squared. 12 equals a times negative 2 squared. This number inside always turns positive. If you're using a calculator, make sure you put the negative 2 in parentheses. 12 equals 4a. 12 divided by 4, a equals 3. All right, y equals 3 times x minus 2 squared. Awesome. All right. C. X-intercepts. 1 and 3. So our formula is going to be y equals a, x minus 1 times x minus 3. Okay, now we're solving for our a. When x is 0, y is 3. All right, 3 equals a times 0 minus 1, 0 minus 3. 3 equals a times negative 1 times negative 3. 3 equals 3a. 3 divided by 3 is obviously 1, so a equals 1. All right? Since a equals 1, you don't even have to put it. 1 times anything is itself. So y equals x minus 1 times x minus 3. Nice and easy. All right. Let's go on to C, to D, and to E. All right. So C, D, and E. Uh-oh, these graphs are upside down now. Does that matter? Of course it doesn't matter. All these upside graphs mean is that your A is going to be what? It's going to be a negative number. Because when A is 0, that's when your graph's face down. All right, so x-intercepts, negative 1 and 3, solve it the same exact way. Y equals a times x plus 1 minus 3. Solve for a when x equals 0, y equals 3. 3 equals a times 0 plus 1, 0 minus 3. 3 equals a times 1 times negative 3. All right? Negative 3a equals 3, and 3 divided by negative 3, a equals 1. So we take our equation, we put a negative 1 here, or just a negative. Negative x plus 1, x minus 3, and y equals 3. Right? And there's your quadratic. Right. Letter E, one x-intercept, and that is only 1. So we're going to have y equals a times x minus 1, you're right, squared. Solve for a. When x is 0, y is negative 2. I'm sorry, negative 3. Negative 3 equals a times 0 minus 1 squared. Negative 3 times negative 1 squared times a. Negative 1 squared is 1. So negative 3 equals 1 times a equals negative 3. Okay, you didn't need to do 2 steps. So y equals negative 3, x minus 1 squared. Right. F. X-intercepts are negative 2 and 3. Y equals a, x plus 2, x minus 3. When x equals 0, y equals 12. Look at this. I haven't made a mistake yet, knock on wood. All right, now just for over us. 12 equals a, 0 plus 2, 0 minus 3. 12 equals a times 2 times negative 3. Negative 6a equals 12, and a equals negative 2. All right? Y equals negative 2, x plus 2, x minus 3. There is D, E, and F. All right, time to take things to another level. By that, I mean just do a different type of problem. So now we're going to do an example like problem 16. In this problem, a difference is you have one of the two x-intercepts, you have the y-intercept, and you have the axis of symmetry. So what you're going to need to do is one extra step is you're going to have to find that that axis of symmetry first, that axis of symmetry, and then you can solve like we did before, right? So this says the axis of symmetry blank lies midway between the x-intercepts. Did I say intercept? Did I say axis of symmetry? Sorry, I meant x-intercept. Find this x-intercept, and then we can solve it like before. That axis of symmetry, what is it? It's x equals 1. It lies midway between the two intercepts, right? We already discussed that when we discussed axis of symmetry, AOSs. Therefore, the other x-intercept, how do we find this one? Remember? Subtraction. You go 1 minus negative 2. We want to find out the distance between these two. It's 3. So that means it is 3 units to get from 1 to negative 2. Can you do negative 2 minus 1? Yeah, you can do that too. You can still get 3. You get a negative 3, but it tells you 3 units. So since we go 3 units to the left here, we have to go 3 units to the right here. So instead of subtracting this, we're going to add 3. So 1 plus 3 will give us our second x-intercept, which is 4. Okay, so you do axis of symmetry minus the first x-intercept. Whatever that number is, you're going to add to your axis of symmetry, and that will give you your second x-intercept. We did this before with axis of symmetries. Quick little review, answers 4. So now, since we have negative 2 and 4, the quadratic is in the form y equals a, right, still a, x plus 2, and x minus 4. In this case right here, we know that a is going to be less than 0. How do we know it's going to be less than 0? Because the graph is opening downward. That's just going to help us later on when we're solving. So, we don't really need to put that, but it's just good information. Next thing, when x is 0, what's y? 16. Therefore, we're going to plug that into our equation. 16 equals a times 0 plus 2, 0 minus 4. 16 equals a times 2 times negative 4. 16 equals a times negative 8. All right? And then, therefore, a equals negative 2. All right? What does that mean? That means now we can do our equation like we did before. We're going to do negative 2. Y equals negative 2, x plus 2, x minus 4. Right? Now I want you guys to attempt problem number 2, A, B, and C. Go for it. We're using the same concept. Let me just get some water real quick. Lost some more waters. Ooh, got some coffee. Nice. All right. X-intercept here is 2. Axis of symmetry is 3. 3 minus 2 is 1. 1 plus 3 is 4. So my second x-intercept is 4. And now guess what? Now we're just solving it like we did problem number 1. X-intercepts are 2 and 4. Therefore my equation is y equals a, x minus 2, x plus 4. Well, that should say a plus. I messed up finally. No. Well, that's right. X minus 2, x minus 4. I don't know why I said I messed up. When x equals 0, y equals 12. We're going to plug that in. 12 equals a times negative 2 times negative 4. When you plug 0 in here, they just disappear. So there's no reason to really write that every time. 12 equals 8 times a. 12 divided by 8 is 3/2. 12 over 8, you take a 4 out of the numerator and denominator, and you get 3/2. So our equation is y equals 3/2, x minus 2, x minus 4. All right, next one. Well, x minus 1 is my axis of symmetry. To get from negative 1 to 4, negative 1 minus 4 is 3. Since I go 3 to the left, I go 3 to the right. Negative 1 plus 3 is 2. My second axis of symmetry, my second x-intercept is 2. You only have one axis of symmetry. X-intercepts are negative 4 and 2. So y equals a, x plus 4, x minus 2. To solve for y, when x is 0, y is 4, right? So I do 4 equals a times 4 times negative 2. 4 times negative 8. 4 divided by negative 8 is negative 4 over 8. Take a 4 to the top, negative 1/2. All right, so y equals negative 1/2, x plus 4, x minus 2. All right. Letter C. Only one x-intercept. So the axis of symmetry doesn't matter. It's x minus 3. So there's no special extra rule to do. So y just equals x plus 3 squared. When x equals 0, y equals negative 12. All right? Now, negative 12 equals a times negative 3 squared. Negative 3 squared is 9. Negative 12 equals 9a. Negative 12 divided by 9, you can take a 3 out of each one. You get negative 4/3 equals a. Y equals negative 4/3, x plus 3 squared. All right? Pretty good. Actually, I like this lesson. This seems like a good lesson. All right. Example 17. Another special thing we're going to do here. All right. This says, find the equation, all right, of the quadratic which cuts the x-axis at 4 and negative 3, and it passes through the point 2, negative 20. So far we found it with 2 intercepts. We found it with all the x and y intercepts. We found it with one x-intercept and the y-intercept and the axis of symmetry. Now we're going to do it with both x-intercepts and the point. Third way to find it. So the first thing, we're going to use the x-intercepts to come up with the base equation with everything but a. And then we're going to use the 2, negative 20 to find our a. So why don't you get stick of that? Try it real quick. All right, since the x-intercepts are 4 and negative 3, the quadratic has the form y equals, remember, a, x minus 4x plus 3. Now, what do you think the graph is? Do you think it's going to open up or down? Any clue? It's actually not going to be 0, so we don't know if it's going to open up or not yet. We know that it can't be 0. Why? Because if this is 0, your graph would be y equals 0, which is just a horizontal line, which is just pretty much your x-axis. So we're going to find that out in a second, though, and then we can tell if our graph opens up or down. So now we got our base form right here, and we're going to use the form when x equals 2, y equals negative 20, and where did we get that from? They gave us the point. So therefore, ready? Negative 20 equals a 2 minus 4, 2 plus 3. You're just plugging in your x and your y in your equation, just as we did before. But instead of these things being zeros, they're going to be actual different numbers. Negative 20 equals a times negative 2 times 5. Negative 20 equals negative 10a. Negative 20 divided by negative 10, a equals 2. Yes, so now we got our a. So now we solve for our quadratic. Y equals 2, x minus 4, x plus 3. There's your answer. Now say we want it in this form. They said give your answer in the form ax squared plus bx plus c. This is in this form. So what do we do to this to get in that form? You're going to have to FOIL. So the first step here would be to take this, x times x is x squared, x times 3 is plus 3x, minus 4x, minus 12. All right? Step 1. Then, you're going to distribute this 2 to all 4 of those things. So you get 2x squared, oh, sorry, not yet, I'm not distributing yet. Go back. 3x minus 4x is negative x. Now I distribute. 2x squared minus 2x minus 24. And there you go. Ax right there. Now we know it's greater than 0. So our quadratic is going to open upwards. We also know it has the y-intercept at negative 24. You can find a whole bunch of things on this. All right? So that's not too terrible, is it? I hope you said no, of course not. All right, so next thing you're going to do problem 3, A, B, C, D, E, and F. All right? My hand actually erases better than my thing. Maybe not. So you're going to do problem 3, 3A, 3B, 3C. All right, so first one, 3A, it cuts through 5, 1, and passes through point 2, negative 9. So this is almost identical to the example problem that we just did, so you should have had no problem with it. If you did, we'll be good after a couple of these. We're going to use that 5 and 1. So y equals a, x minus 5, x minus 1. Okay, so we used the y-intercept to set up our base equation. Now we're going to use this point to solve for a. When x is 2, y is negative 9. All right, so negative 9 equals a, 2 minus 5, 2 minus 1. Negative 9 equals a times negative 3 times 1. Negative 9 equals negative 3a. Divide by negative 3, and a equals 3. Y equals 3, x minus 5, x minus 1. Okay, so this is how we were writing in problems 1 and 2. However, this is find in the form y equals ax squared plus bx plus c. So now what you're going to have to do is you're going to have to use your rules. You take your, right here, x squared minus x minus 5x plus 5. All right, they're going to combine like terms. Negative x minus 5 is negative 6x. Sorry, negative x minus 5x. And then you're going to distribute your 3. All right, 3x squared minus 18x plus 50. That's all there's to it. All right. Go try problem B. Another one, very similar, if not the same, to what we just did. All right. Once again, y equals x minus 2, x plus 1/2. Remember the signs are opposite. That's one of the biggest mistakes made. We're going to use when x is 3, y is negative 14. Right? So negative 14 equals a times 3 minus 2, 3 plus 1/2. Negative 14 equals a times 1 times 3 1/2. or times 7 over 2, or times 3.5. You can use any of those things you'd like. This becomes 7/2 a equals 14. Now, in order to get rid of that 7/2, you're going to multiply it by the reciprocal, which is 2 over 7. All right? Now, this becomes negative 28 divided by 7, which is negative 4. Okay, so that's what a equals. Plug it into that equation. Y equals negative 4, x minus 2, x plus 1/2. All right? Still following? Next, x squared plus 1/2 x minus 2x minus 1, negative 2 divided by 2 is negative 1. All right? Negative 2x plus 1/2 x is negative 3/2 x. So I just did that. I just skipped this middle step. I'm going to be skipping that, you know. And the last step is take your 4, distribute the 4. 4x squared minus 12 over 2 is 6x. And then you got minus, 4. Right. Where's that minus 10 come from? Bad 10. All right. Any questions with that one? That was pretty simple, right? Next one. All right, you're going to C and D. Now they're touching. You got things touching. Touching's good. Touching's easier. That means that we're setting it up in a different equation. That means there's one less step, pretty much. No, not really one less step. One less piece of the step. Y equals A, because it touches, this is going to be x minus 3 squared. Okay, so that's our basic form that we're going to use. That's like our template. When x is negative 2, y is negative 25. Negative 25 equals a times negative 2 minus 3 squared. Negative 25 equals a times negative 5 squared. Negative 25 equals 25a. A is negative 1. That's easy. Negative 1 times x minus 3 squared. Now, normally we just leave it like that, but we can't. Now, this gets a couple students, even some of my calculus students. X minus 3 squared, when you expand that, this is just x minus 3 times x minus 3. That's all you're really doing there. Okay? So your answer is not, some people just go, oh, x minus 3 squared, that's x squared plus 9. No, you forget the middle piece. Because what happens is you got x squared minus 3x, which is minus 6x, and then you have your plus 9. So you can't forget your middle piece. All right, you're going to distribute the negative to all this. Negative x squared plus 6x minus 9. Do problem D, very similar to problem C. All right, you should be done. Y equals a times, since this is negative 2, is going to be x plus 2 squared. When x is negative 1, y is 4. 4 equals a times negative 1 plus 2 squared. 4 equals a times 1 squared. So 4 equals 1 squared is 1. 1 times a is just a. So a equals 4. Y equals 4, x minus plus 2 squared. When you expand this is x plus 2 times x plus 2. All right? And you could also use a formula here. The formula is a squared plus 2ab plus b squared. We can get into that later, but you're going to end up with x squared plus 4x plus this. And what I'm saying is, perfect squares, if you have a plus b, say, squared, what this equals is a squared plus 2ab plus b squared. So what that means is a squared, x squared, 2 times 1, 2 times x times 2 is 4x, plus 2 squared is 4. So you can use this formula if you want. You don't have to. This is how I usually do it. You can always expand and do it. That is up to you. Anyway, we're going to distribute 4, and you get 4x squared plus 16x plus 16. Right. That's C and D. And now we're doing E and F. Let's see, is E and F any different? Oh, this one cuts it at x, has an axis of symmetry of 2 and a point. So now we're doing a little different. Now we have a point, we have an x-axis, one of the two x-axes, and the axis of symmetry. So the first step you're going to have to do is you're going to have to find the second x-axis. So if this is 2 and this is 3, 3 minus 2 means you're 1 away. So 2, go the other way, minus 1 is 1. That's your other x-intercept. So my x-intercepts are 3 and 1. So in order to solve our question, y equals a, x minus 3, x minus 1. When x is 5, y is 12, right? 12 equals a, 5 minus 3, 5 minus 1. 12 equals a times 2 times 4. 12 equals 8a. 12 divided by 8, 12 over 8 reduces to 3 halves. Alright, so y equals 3 halves, x minus 3, x minus 1. Expand this, x squared minus x minus 3x is minus 4x plus 3. 3 half x squared minus 12 over 2 is minus 6x plus 9 over 2. Alright, do problem 4. Alright. Cuts it at 5, axes at 1. So if you really think about it, you're going to cut it at 5 over here. You have something coming down at 1. So you know your other one's over here. It's going to be, oops, sorry, this is 5, this is 1. It's going to be something over here that's negative, right? So I do 1 minus 5. Or 5 minus 1 means I'm 4 away. Means this is 4. So I go 4 this way, 1 minus 4. And 1 minus 4 is negative 3. Which is my other intercept. Y equals, my two intercepts are negative 3 and 5. So you have x minus 5. And you have x plus 3. Trying to solve for a. When x is 2, y is 5. So 5 equals a times 2 minus 5, 2 plus 3. 5 equals a times negative 3 times 5. 5 equals negative 15a. 5 divided by negative 15 is negative 1/3. Y equals negative 1/3, x minus 5, x plus 3. X squared minus 5x plus 3x, that's minus 2x, minus 15. There's your x squared, where is that? 1/3 out front, and this is a negative 1/3. You distribute it, negative 1/3, x squared, plus 2/3 x. All right, plus 5. Okay, pretty easy. All right, let's do the last type of wait. Yeah, pretty much the last type problem. All right, now we're gonna get back into calculator work. Oh, this is a fun one. Fun. I'm going to show you this with and without the calculator. All right, so, you don't want those circles up there, do you? Find the equation of the quadratic function, which has 3 points. Now we can do this with 3 points, and the best way to find a quadratic with those 3 points is simply using technology. So what we have to do is we're going to have to set up 3 equations, and after we set up those 3 equations, we're going to type them into a simultaneous equation solver in our calculator using these rules, and then we're going to be good. So, first thing, when x is negative 2 and y is 5, we're going to use the formula ax squared plus bx plus c equals y. Okay? I didn't put the equals y there. Alright, so, watch how we start off. I plug in the x for x, and it equals y. Alright? So, number 1. It says negative 2 squared, a times negative 2 squared, right? Plus b times negative 2, all right, equals y. Got it? So what do we do? Do we have any questions or concerns? How are we doing this? So what we're doing is now we're going to square the numbers and we're going to solve. So what does that mean, square the numbers and solve? What that means is negative 2 squared is 4, 4a minus 2b plus c equals 5. So we use these two things to create an equation. So why don't you guys create the other two equations? Go. All right, so to create this equation, a times 1 squared plus b times 1 plus c equals negative 4. All right, well 1 squared is 1 times a is just a plus b plus c equals negative 4. That's pretty easy. Ready for the next one? C. When x is 3, y is 5. So we're going to plug in 3 for x. A times 3 squared plus b times 3 plus c equals 5. 5. Let's just say 10, I think. Equals 10. Whoops. So it equals 10. All right, so what you're doing there is, now I know it doesn't equal 5 because you're not going to have two x's for the same y. 3 squared is 9, 9a plus 3b plus c equals 10. Right? Now in your packet, it actually says 5, 2, but it should say 10. All right, I'm going to fix that. Don't worry. When we solve the system of equations simultaneous, we're using technology. Now here's the technology we're going to use. It's very important that you follow along here. All right. Now the first thing we're going to do is we're going to take those technology and we're going to take our calculator out. All right. When we take our calculator out, we're going to hit the apps button. You're going to hit apps to go to number 9, PL SMLT2. Hit number 2, simultaneous equation solver. Select 3 for the equations and 3 for the unknowns. So we have our equations here. So our x, y, and z are going to be 4, negative 2, 1, and our y is 5, 1, 1, 1, negative 4, 9, 3, 1, and 10. It should look something like this down here, which you can't see. And when you type it into your equation, you're going to get something. I like doing this way better. So I take this. You can see the equations on the left kind of still. First thing I hit is apps. The apps button is to the bottom right. Here's the light green. Go over 1, down 1, apps. All right, go down to number 9, PLY SMLT2. Hit enter. Hit enter. It brings you to the main polynomial root finder. That's how you find the square roots. We did that before. We're going to go down to number 2 now, simultaneous equation solver. You're going to hit enter. Now, I have 3 equations, so I go from the number 2 over to the number 3, and I hit enter. I have 3 unknowns. I have my A, B, and C. So I go to number 3 there. If I know C, I don't have to do this. So I have 3 and 3, and then I'm going to hit the next button, which is the graph. And it brings me to this. And now, as I said before, we're going to plug in our stuff. 4a minus 2b plus c. So I type in a 4a, hit the minus button, hit 2b, enter, plus 1. Anytime you just have a thing, it's a 1. C equals 5. Okay, they use x, y, and z as opposed to a, b, and c, which is okay. Next one is a plus b plus c is negative 4. So that's 1x, 1y, 1z, and you're going to use the negative number. Negative button is down here. Do not use minus. Go negative 4. Okay, that's how you do that. In there. 9, 3, 1, and 10. So 9, 3, 1, and 10. All right, so I've got my equations. This is what your thing should look like. And the last step is very simple. You're going to hit the graph button so it says solve. And then what it will do is it will shoot out your solution. It says x is 1, y is negative 1, and z is 5. That's your a, b, and c, your x, y, and z. So a is 2, b is negative 1, and c is negative 5. So let's go back to here. A, there's our solution. A is 2, B is -1, and C is -5. So now when we put this back in our function, this is 2x squared minus 1x, or minus x, minus 5. And we're done. Bam, wasn't that fun? No? That's it. Okay. All right. Go on to number 4. You're going to do this one on your own. All right, so you do number 4 on your own. All right, let's check this out. State the value of C. All right. First off, can we figure out what C is, what our y-intercept is? We can do that from just looking at this graph, or by making x equal to 0. So by looking at this graph, what's C going to be right here? It's your y-intercept. So your C is 2. So right away, this makes everything easier. Now, if you have 3 unknowns, you need 3 equations. You need 3 points. If you have 2 unknowns, you only need 2 points. So we only need 2 points because now we only have 2 unknowns. Okay, so we're going to change this up a little bit. So now that we know C is 2, this equation is technically ax squared plus bx plus 2, right? Now, when x equals 1 and y equals 1, I want you to write the new equation. Go. All right, so what you should have wrote was a times 1 squared plus b times 1 plus 2, which is your C, equals 1. A plus b plus 2 equals 1. So I'm going to subtract 2 from both sides. 1 minus 2 is -1. So you got a plus b, and all I did here, you don't need to see it, is I subtracted 2 from both sides to get -1. So they got a nice, teeny, good equation. Right? Now we're going to go to the next part. What do we do next? This one. All right, let's see if you got that. You have x is 2, y is 6. And remember, the equation here would change to ax squared plus bx plus 2. So, ready? A times 2 squared plus b times 2 plus 2 equals your y, which is 6. 2 squared is 4. 4a plus 2b, we're going to subtract 2 from both sides. And 6 minus 2 is, you got it, 4. So it's 4a plus 2b equals 4. Take those equations, and now we're going to use our technology. Now, using technology, you should still have this graph up here like this, kind of, right? Try to get this without messing this up. Got to move over here. Oh, let's see. All right, so I got this still over here, right? So I'm going to go back to main. All right, I'm going to go to number 2 still. Hit enter. All right. I'm going to go to unknowns now is just 2. Okay, because I just got A and B I'm looking for. I already know C. Equations is also 2. I said that backwards because I only have those, the red and the blue equation. I hit next. All right. Now it's a plus b is -1. So I'm going to hit 1 for a. 1a plus 1b equals -1. All right. And then I have 4a plus 2b equals 4. So 4a plus 2b equals 4. All right. I checked my signs. They're all pluses except for that one. I'm going to hit the graph button right here. And I get my solution to be 3 and -4. So A is 3, B is -4. All right, so once again, let's see. Let's make sure this is good. My equation says A is, type it in right here, A is 3, B is indeed -4. All right, and we already know that C is 2. How do we know it? Because we found it to be 2 all the way up here. So when writing out the equation, I got f of x equals 3x squared minus 4x plus 2. That's it. That, my friends, is number 4. All right, so now I want you to do problem number 5. Problem number 5. 5 has an A, B, and C to it. Yes or no? Right. So use your calculator. I'll do all this calculator work with you on the computer for you. All right, so A, let's create the equation first. Because of there being 3 points, you're going to use the 3 simultaneous equations you're going to need to make. All right, and we're using ax squared plus bx plus c equals y as a template, like I said before, for all of them. So a times 1 squared plus b times 1 plus c equals y, which is -2. A plus b plus c equals -2. That's equation number 1. A times 2 squared plus b times 2 plus c equals 4. 4a plus 2b plus c equals 4. These numbers, this is always going to be the square of this number. So all right, 3 and 12. A3 squared plus b3 plus c equals 12. 9 plus 3 plus c equals 12. All right, so now I got a bunch of stuff going on here. All right, I got 3 fun equations. Now right here, my calculator work back here. Oh, you can see my reflection kind of. All right, you can see how I'm videotaping this down. All right, so I got my thing right here. I'm going to go back to main. All right, I'm going to go to my number 2 simultaneous equation solver. Now I'm going to go over to 3, enter, and 3, because I want 3 equations now. And I'll be there for the next 2 problems as well. I'm setting this up. My first one is 1, 1, 1, and -2. Not -2, -2. My second one is 4, 2, 1, and 4. 4,
Pardon the interruption. Anybody owning a blue Ford, license plate 788H, Jersey Shore plates, can you come to Mr. Bandinelli's office?
9,
Thank you.
3, 1, 12. All right, and then I hit solve. I get 1, 3, -6 as my things. All right. Got it? All right, 1, 3. -6 is my A, B, and C. All right, so right there. 1, 3, -6. So I got x squared plus 3x minus 6. All right. Any questions involving problem 5? No? Awesome. All right, we're going to go down now to problem number 6. All right, problem number 6. Set it up and solve it. All right, x, -1 squared plus b times -1 plus c equals 3. All right. A minus b plus c equals 3. Second one, a times 2 squared, b times 2 plus c equals 9. You get 4a plus 2b plus c equals 9. A times 4 squared times b times 4 plus c equals -7. 16a plus 4b plus c equals -7. All right. You're going to take these 3 things, plug them into your equation, and you're going to solve. All right. Now, let's go look at this real quick. The way this works is you go to main, simultaneous equation solver. Once again, I am already where I need to be. It's already here at 3, 3, 3, and 3. I hit next. I got some stuff up here already, but it doesn't matter. I'm going to go 1. B is -1. C is 1. And I got 3. All right, this is 4. 2. Oh, I don't even have to put anything on 1. And 9. All right, this is 16. 4. 1. -7. All right, so I got my system of equations right here. I am going to hit solve. I get -2, 4, and -9. All right, just using technology to get all these answers. So I check my answer with this, and it says -2, 4, and 9 indeed. So it's y equals -2x squared plus 4x plus 9. All right. Problem C. All right, the way problem C works is you're going to set up the equations again, and you're going to solve. All right, so set up and solve. First thing, A equals -8 squared plus B times -8 plus C equals 4. 64A minus 8B plus C equals 4. All right, next one. X is -4, B is -8. So -4 squared plus B times -4 plus C equals -8. 16A minus 4B plus C equals 8. These A's are always going to be positive because when you square a negative number, it's positive. A times 6 squared plus B times 6 plus C equals 32. 36A plus 6B plus C equals 32. Go back to our calculator. We're going to type in some more stuff here. Let's go back to main. Hit the main. You don't have to go all the way back out. Go back here. 3, 3. Excellent. So now I'm going to do this. Okay, I got 64. I got -8. Good. I got 1. Whoops. 1. And I got 4. All right, this one I got 16. I got -4. I got 1. And I got -8. Whoops, sorry, I'm off the screen. This one I got 36. I got 6. I got 1. And I got 32. All right, so I got all my stuff typed in here. I'm going to cross my fingers when I hit solve. 1/2 for A, B is 3, and C is -34. All right. Now I go, and I type those in after I get my nice good chart right here. All right, 1/2, 3, -4, and I put it into my equation. Y equals 1/2 x squared plus 3x minus 4. And that completes problem number 5. That's a pretty long problem, but it's not too terrible. All right. All right, so now we're on problem number 6. Oh, last one. Pretty much. Oh, that is the last one. Problem 6. Good. All right, so problem 6, 7, 8, and 9. 6, 7, 8 in the activity. So problem number 6 right here says to try to find the equation of the quadratic which passes through those points. The same thing we just did. So go do another problem like this. All right, should be done once again. A times -1 squared plus B times -1 plus C equals 7. A minus B plus C equals 7. Equation number 1. Equation number 2. A times 2 squared plus B times 2 plus C equals 1. 4A plus 2B plus C equals 1. Pretty good. All right, next question. A times 3 squared plus B times 3 plus C equals -1. 3 squared is 9. 9A plus 3B plus C equals -1. All right. Any questions regarding No? So now we're just going to go into our calculator. Now going into our calculator, what you should be doing is you should be typing in 1 minus 1, 1, and 7. 4 minus, 4 plus 2. Oh, this should be a plus. Plus 2, 1 and 1, 9, 3 and 1, and negative 1. All right, so when you do that, you end up with your A being 0, your B being negative 2, and your C being 5. So y equals negative 2x. In case you're wondering what I just did right there, once again, I went to here. I have my, oops, get over there. Got all my stuff in, 3 and 3. I go through my stuff. I go 1 minus 1. My z is 1, and you are 7. Good. This is 4, 2, and 1. 4, 2, 1, and 1. That was a nice one. And the last one is 9, 3, 1, negative 1. All right, went here, did all this, hit solve, 0, negative 2, 5. Now, if A is 0, what does that mean? Is this a quadratic equation? Actually, the equation is y equals negative 2x plus 5. However, it's not quadratic. This is a linear equation that has a slope of negative 2 and a y-intercept of 5. So this is not a quadratic equation. Even though we were able to solve it this way, because A is 0, you need to have at least a number, a fraction, a decimal, something here for A. All right? Good. Problem 7. Almost there. This is a quadratic function. Passes through this. So first thing I want you to do is plot these 3 points. 1, negative 1, 2, 1, and 5, negative 5. All right, you plotted them. There we go. 1, negative 1. 1 over 1 down. 2 over 1 up. And 5 over 5 down. All right, those are the graphs right there. Explain why the following. Why must A be negative? Why must C be negative? And why must B be positive? Well, let's look at this graph real quick. What way do you think it's going to be opening, up or down? Well, looking at the graph, if I want to connect it, it looks something like this. Because this piece is between these two, it obviously means it's going down. So A must be negative because the graph is opening downward. Anytime the graph opens downward, A is negative. So I don't even have to solve anything. Now, why must C be negative? Well, look at it. If you're going from here to here and you're still on the right side of the equation, you're not going to, the C is your y-intercept. Right? The y-intercept is somewhere below this x-axis. Therefore, C has to be less than 0. Therefore, it must be negative. All right. Why must B be positive? B is positive because the vertex, right, negative B over 2A, right, is greater than 0. How do we know it's greater than 0? Because the axis of symmetry is right around here. So this number is greater than 0. And since A is less than 0, negative and negative is a positive, B also has to be a positive. So that's why B has to be bigger than 0, because it's going downwards and the axis of symmetry is positive. So you already have 2 negatives, you can't have a third. There you go. 7 was just a nice hypothetical question. We're going to finish up with number 8. Good. Quadratic function. Use technology. So we're going to do what we just did in problems 6 and 5 again. All right, let's go check it out. A times 1 squared plus B times 1 plus C equals 0. A plus B plus C equals negative 1. Awesome. A times 2 squared plus B times 2 plus C. 4A plus 2B plus C equals 1. Okay, good. Now we have 5 and negative 5. A times 5 squared plus B times 5 plus C equals negative 5. 25A plus 5B plus C equals negative 5. All right? All good? Now, in order to find our A, B, and C, we're going to use our calculator. All right, so when we're using our calculator, we're back in here. Oh, I got a solution up there from the last time I did this. So I want to use my calculator. I'm going to click on to the right over here. Boop. I'm going to click on to the right over here. All right, now the way this works is very simple. I'm going to go main, simultaneous equation solver. I have 3, so that's good. I hit next. I got 1, 1, 1, and negative 1. So 1 plus, so I've got to put my plus in there, 1 plus 1 equals negative 1. All right, that's not too bad. 4, 2, and 1, 4a plus 2b. Notice it's always at the same lot. Plus 1c, oh, equals 1. That's the same point I had before. Now this one is 25 plus 5b plus 1c equals negative 5. Graph. Negative 1, 5, and negative 5. All right, let's go check to make sure that that is indeed our answers. Negative 1 is A, B is 5, and C is negative 5. So we can find the equation now. Let's use our technology to find this equation. All right, so this is actually the second half of 7, that's not 8. Negative x squared plus 5x minus 5. So now we can actually find the vertex. And now what do you see? You notice our A is negative, our C is negative, our B is positive. So in order to find the vertex, we have to use our formula negative b over 2a. Our b is 5, our a is negative 1. So it becomes 5, negative 5 over 2 times negative 1. 5 over negative 2, which is our x. That's our axis of symmetry. Okay? So this is the x of our vertex, because that's your axis of symmetry. And in order to find our y, we take this 5/2 and we're going to plug it in for the x. And that will give us our y value. So you do y equals negative 5/2 squared, which is negative 25 over 4, plus 25 over 5 minus 5. Y equals, you want to get the same denominator for all these so you can add them. Multiply by 2 over 2, multiply by 4 over 4. Negative 25 plus 50 is 25, minus 5 is 5/4. So what this tells us here is this is our y value. All right, so this is either our maximum or minimum. So this is our x, this is our y. Our final answer is 5/2, 5/4. And that is where our vertex is. That's the point. All right, so you go over 5/2. So 2.5, 1 1/4. So if I was going to go all the way back to this graph, 2.5, 1 1/4 up, right there, that's our vertex. See that? Pretty good. All right. So, last problem. Problem number 8. Quadratic function f of x equals ax squared passes through 5, 3. Use that information. 2. Write the 3 linear equations in terms of a, b, and c. Oops. All right, so first thing, how are we going to do that? Well, we have 5, 3, and 3, 7. So what that means is, if you think about that, 5 over 3 up, so 1, 2, 3, 4, 5, 1, 2, 3 up, right? That's 1. The other one is 1, 2, 3 over, and then 7 up. All right? And this is a vertex, this is a point. So our graph is going to look like this, and it does the same thing to the left. All right? So since this point right here goes over 2 this way, and it goes down 4, it's going to do the same thing here. Over 2, down 4. So we can actually find a third point that way. Now the way you're going to find the third point is you're going to take your 5 and your 3. All right? 5 minus 3 means it's 2 away. So I'm going to go 2 to the left. So that's why right here is 5, This is my vertex at 3. I go to 1. Now I need to know how high it is. It's going to be the same height as our point. Okay, the other point's at 1, 3. So its y value is going to be the same. So 1 over 3 up. So you got 5 over 3 up, 1 over 3 up. And you're going to see it when I sketch the quadratic function down there. All right? So next thing we're going to do, very simple, is what? Because this is the same as the y value. That's where you get the 1 from. All right? Now we're going to do our 3 equations. First equation, 5, 3. When x is 5, a times 5 squared plus b times 5 plus c equals 3. 25a plus 5b equals plus c equals 3. Second equation, we're going to use our vertex, xy. A times x squared plus b times x plus c equals 7. 9a plus 3b plus c equals 7. Third point, we're going to use our new point 1, 3. A times 1 squared plus b times 1 plus c equals 3. A plus b plus c equals 3. All right? So you just had to create that one nice point. All right? All right? What am I looking for? Calculator. Oh, there it is. Last things we're going to type in here for our calculator. You really can't see it up there. All right, so once again, I'm in main mode. I'm in 3 and 3. So I got my system of equations here that's not right. So I'm going to type them in to make them right. I got 25, enter. I got 5. I got 1. I got 3. All right, then I got 9. I got 3. I got 7. Oops, sorry, I got 1 and 7, so I can just press back. I go 1, 7. Here I got 1, 1, 1, 3. All right, so those are my answers. I hit the solve button. Hopefully I get the right answer when I solve it. I've been doing so good. It says, what does it say? -1, 6, and -2. So let's check this out. Answers are indeed -1, 6, and -2. So our equation, y equals x squared plus 3x plus 6. All right, now we probably should have did c first, because what I was trying to do was, I was actually trying to show you how I found the graph using c. So what I'm going to do is 1, 2, so when you graph C, you have your vertex, which is 3, 7. You have your other point, which is 5, 3. So what I was saying before, since this is 2 to the right, our other point has to be 2 to the left. Because this is 3 up, this one also has to be up, and there's our graph. All right, so that's how we found the second point. All right, nice, exactly. All right, last one. Activity. We're not really going to complete this activity, but what I would like to do is just show you how the activity works for you guys to complete on your own if you'd like. All right? Now, this is just a card game. If you go to page 152 and click on the card game activity right here, what it will do is it will bring you to card game, give you instructions, and then show you how to play. What you're going to do is you're going to match things up here. For instance, these are the axis of symmetry pieces here, the vertex here, and you want to match whatever it is. So the vertex, I got to figure out, okay, the vertex, I don't know what that is. Y equals x squared, I don't know. 1, 3, it intersects twice. So you just got to figure this out. So like vertex right here, oh, I know that goes here. All right, yay, I got some points. Vertex right here. Oh, I got it right, good. I went here. Oh no, I got it wrong. Like you can mess up stuff, okay? Axis of symmetry, did I get it right or wrong? You just have to figure it out. And then you're gonna do it as quick as you can, see what you get, and hopefully you do good. All right? In the meantime, though, I would like to express my gratitude and just you guys have been doing really good at this stuff. I know it's a little tough to do at home a lot of times, but I think you're really getting this, and now I think I know how to find the quadratic equations from a graph. Hopefully this lesson was beneficial to you. All right, and then until I see you guys next time, have a great day.